Oh, welcome back, everyone. We have our last but not least presentation of the day and of the conference, actually. So it's my pleasure to introduce Lale Madhali from the University of Nebraska. She's presenting us a paper titled Application of the Benford's Law to Social Bots and Information Operations Activities. So welcome, Lale, and so you should be able to control your slides from your laptop, and you have more or less 20 minutes for presentation so that we leave enough time for questions at the end. Over to you.
Thank you so much. Hi, everyone. This is Lale. I'm a graduate student at the University of Nebraska at Omaha, and I'm working on social bots. And in this paper, I work on application of Benford's law to social bots and information operations activities. So should I only hit enter or?
If you click, yeah.
Okay.
There might be a bit of delay.
Yeah, it's a little bit slow, I guess. Okay, thank you. So what is Benford's law? Benford's law is actually one special case of power law, but it's not usually referred to as a special case of power law. It's actually the first time a researcher found that, his name was McGibney, found out that in the library, the first few pages of a book is more wear out and old and compared to the last pages. So they try to come up with a law, and they cite in many different fields like accounting, financing, finance, stock market, survey data. I've seen it in natural science, which was actually in earthquake data, as well as religion. This law actually says the first digits are more common and more frequent than the last digits. Like using one is more frequent, digit 1 is more frequent than 2, it's more frequent than 3, 4, 5, 6, 7, 8, 9, and 9 is the least frequent digit in everything. So it has applications in different fields. And this is a formula that usually try to describe it is logarithm 1 plus 1 over d, which d is the digit, and the logarithm base is 10. So Benford's law have been tested on social networks, saying that there's a paper published in PLOS ONE journal which says that so if we have a natural network, complex network, whether it is protein network, whether it is social network, authorship network, citation, collaboration, friendship, or whatever, if it's a natural network, it should follow the Benford's law. However, in this research, I'm working on social bots activities. What is a bot? Bots are actually automated accounts on social media. They're actually very similar to robots, but in online world. So robots in online world help us doing so many things. And bots also in social media can be helpful as well as malicious. So to give you an example, Wikipedia. Wikipedia is the largest encyclopedia, and it has many bots, and I've worked with them. So those bots actually are really helpful and so nice. They're helping in avoiding vandalism, quality control, and vulgar and things like that. And they're doing a good job. You can just give it a try. You can just go and write something which is a little bit unrelated to the topic, and then in less than a minute, some of the bots come and revert your edit, which is kind of cool. So bots are there in many online media, and even in GitHub. GitHub is an open source, is actually a platform for open source collaboration, for collaborating open source projects and things like that. There are bots there. They open issue, close issue, they add labels and things like that. They sometimes might be argumentative. They might argue in Wikipedia as well as GitHub. And on Twitter, this is the platform I'm using, and Twitter bots can be malicious and helpful. However, Twitter doesn't require people to name their bots identifiable. What does that mean? In Wikipedia, they have a policy that if you're writing a bot, the name is obvious. It should include the name, the characters BOT, so that other people know this is a bot. But on Twitter, you cannot detect. Anyone can create some bot. I even created a bot which retweets whatever, but if you give them a hashtag, they can retweet, they can follow, they can unfollow, they can block people. So they're in fact, they get triggered based on some functions you define for them. And so they can impersonate real people, and their main application is using in misinformation and disinformation, especially during like elections, during really important events like outbreaks, crises, and things like that. That's why in this study, I'm planning to study social bots on Twitter, whether they follow the Benford law, which is a law of naturally occurring systems, or not. Information operations. Information operations are actually activities run by foreign agents and influence campaign to spread misinformation and disinformation. And they can use automated accounts or non-automated accounts, but usually those accounts are paid, so they're not usually automated. And sometimes some research call them trolls. Some of them say no, it's just a special type of trolls. But they can amplify rumors. They can amplify bad news. They can get the information of people, like private information. So both bot activities and information operating activities can somehow be malicious. And the data sets I'm using, actually both of them include malicious and anomalous behavior. So we're trying to address this research question. Do information operations activities and social bot activities adhere to Benford law? And expectedly, we expect them not to follow. And of course, our research has implications for social media designers, because Twitter each year they're suspending thousands and millions of accounts, and these accounts I'm working with, they actually have been suspended. And even bots, catching bots for like social media designers as well as human beings. So sometimes it happened to me, like personally, or to so many people. We follow some accounts, but they're bots, and we're not even aware of. So it has implications for social media users as well as designers. The data sets I'm using for social bots, I'm using 3 benchmark data sets. The first one is called Social Honeypot from Texas A&M. It's used by them. It's actually, they wrote a code that creates fake accounts, and then other people, it's like a honeypot, and then they consider whoever is attracted to those accounts as a bot or fake account. And they published a paper in some these works are actually among the pioneer works in social bot research. The other one is another series of data. It's called Social Spam Bot. Created by Stefano Cresci. Their team is also actively working on social bots. And the other one was a data set which is annotated manually. That's the difference between this data set with the other two, from Cambridge University. So it's like the group of 4 people sit and decide whether this account seems like a bot or not. And for information operations data set, and I'm using IO, stands for information operations. I use 7 very, very big data sets released by Twitter. Twitter calls them elections integrity data. So, and then Twitter believes that these accounts and data sets and tweeting networks are state-backed information operations, and there are from countries like Russia, Bangladesh, Venezuela, and Iran. So 2 sets from Russia, and I think 2 sets from Bangladesh, and 1 set from Venezuela and Iran. And I used 3 tests, Pearson chi-square, Mantissa arc test, and mean absolute deviance. For more information and detail about what they do, what is the test statistic, what is the degree of freedom, and things like that, you can definitely refer to my paper, and also distortion factor. But the good thing about all these tests is that I decided to do a voting. Like sometimes, like let's say Pearson and MAT says this conforms to the law, the other one says it doesn't. And I use distortion factor to compare the means, to compare whether it deviates from the distribution or it doesn't. And this is hope and thankfully I had most of the usual features that we use on Twitter, like followers, following, tweet count, or favorite count, number of replies, and things like that. For most of the data set, Zafar Gilani's data set was a little bit different. And this is some of the results. And so the first, if you look at the figure, the left figure, it is, you can see two figures, the left one and the right one. Both of them are for, all of them are for the first digit. The left one is actually for bots. The right one is for humans. As you can see, the left one, the digit 1 is so frequent, the most frequent. 2 is very frequent, and then 3, 4, 5 are not that much. 6, 7 are not that much, but 8 is the next most frequent digit. However, for the humans, this look at the number of their followers. 1 is the most frequent, and then 2, 3, 4, etc. So, and I don't rely on the figure. So we have 3 tests, and of course, I use p-values and p-values, figure, and things like that. And for the right one is for a status scan or the number of tweets. So for all of the bots data sets, we found that bots features deviate. They don't follow the distribution. But except for Zafar Gilani's data, the data set which was annotated manually. As you can see, we cannot say human behavior follows the Benford's law, but bot behavior does not. So we couldn't find any consistent patterns in Zafar Gilani data. Maybe it is related to how they gathered data, or maybe it wasn't that accurate, or maybe even we do it manually, the result is different from the fake accounts we catch is different from when we catch fake accounts and bots using code and social honeypots. And regarding information operations, so again, we couldn't find any sort of like law which says, okay, this is anomalous behavior, therefore it doesn't follow the Benford's law. So nothing followed Benford's law, and some features did, some features didn't. Therefore, we cannot say strictly information operations activities deviate from the law of naturally occurring systems. Maybe future research can consider different set of information operation tweets or different set of information operation data from Facebook. Conclusion. Therefore, in this paper, we in this research, I analyzed and investigated whether the anomalous behavior in social networks follow the law of naturally occurring systems or not. And findings indicate that real accounts for sure conform to the law, and bots accounts do not conform to the law. However, we cannot say it strictly and certainly for information operation activities. And actually, the data set I used, it was a huge data. However, Twitter used the same strategy to detect, to capture and detect and suspend them. Maybe different information operation data, like this was about like elections, more around 2016 US elections. And I actually analyzed it. So they were not that active. But during 2016 US elections, especially the Russian accounts, were really active. So we couldn't find any special sort of pattern, so we cannot say for sure. And our research, as I mentioned, like I said before, it has implications for analyzing and characterizing anomalous behavior in social networks and for cybersecurity for sure. And future research can include, like prospective researchers can include other bots. We have malicious chatbots, we have web robots, we have even dark web. We have many automated accounts which try to impersonate real. Not all of them are malicious, some of them, but we're trying to characterize the malicious ones. What is the difference between the people who are honest about their identity on social media compared to people who are not? And that's it. Thank you so much for your time and attention.
Thank you very much. Very interesting presentation, Lale. We have a few questions for you. So the first one is, what was the most important feature in your feature set?
So I wouldn't like consider it as the most important or least important. So in social media, usually the features we try to like consider are follower counts, following count, status count, favorite count, replying. However, previous research shows that follower to following ratio can be a good indicator of fake accounts. Let's say I create a fake account and I try to follow many people. So usually bots and fake accounts follow many people, but they're not that successful to gain many followers. That's why the follower to following ratio can be a really good feature, but I examined everything. And even in the data set which deviated from the like Zafar Gilani's data, even in that data set, following to following ratio was really important, but for humans and bots, it showed the same behavior.
Okay, I think you kind of answered also the second, at least partly the second question that we had, which is, what are different behaviors between human and bots? But is there anything else you would like to add to what you have already mentioned?
Mm-hmm. So the difference is that so I cannot be, we're still trying to say it's not easy. Like when you look at an account, you don't know whether it's a bot or it's a human. And more like sometimes there's a guy behind an account. The account looks like a 20 years old woman, but there's a guy behind that. Sometimes it's tough to say, sometimes it's not. So I've been examined so many times, like there are some accounts that look like they upload pictures of pretty women, but you see like the behavior of their posting is a little bit weird. So they post in bursts. Sometimes they post many like tweets, or on Facebook, they update their status like for so many times in a short amount of time, and then they go away and then they don't come back. So they post in bursts sometimes. This can be one indicative. And then their friends, their followers can be indicated, but still there are so many people who fall victim. So many people.
Yeah, I think personally, I work with social media data sets too, particularly Twitter, and we were lucky to have all the tweets around Brexit. And then, as you might know, there was lots of discussion around the use of bots in the Brexit discussion and in the US debates and the US elections. So we got the list of those bots that were supposed to be Russian bots. I don't know where they came from, to be honest. But anyway, the bots that were identified by the US authorities as well. And what we noticed there, we filtered them out. And what we noticed just looking at the tweets there were some very sophisticated bots where they not only posted very quickly, but they constantly changed the text of the tweet, the bio, and the pictures. So essentially, if you scroll through, you don't realize it was the same bot or the same account tweeting through. So that's something else that you might want to think about.
Yeah, actually, 2 papers show that bots retweet more than tweet original content. So their content is not original. They retweet more than they tweet. And they upload their tweets usually include more links, more URLs, and also they usually upload bulkier media, like more voluminous like how should I say it, like more high volume media pictures and things like that. So actually bots in all platforms are leveraged, are used as a tool to spread, to do some repetitive mundane tasks. They're not as smart as human beings. Theory of agency, authorial agency does not apply to them still. So we create them. So they're just algorithms. They do whatever we want them to do. So they tend to do more repetitive stuff than smart or intelligent stuff. And the conversational networks, other research also shows that it is less dense. It has less clustering coefficient compared to humans' conversational networks.
And then I don't know if you might know this already, but there is, I'll just put this in here in the chat, so you also have the link just in case. Yeah. So there is this bottom.
Yeah, I know that.
So,
from Indiana University, yep.
So have you tried to see how your results, your system compares to the results that they get, say, or if you just use the same account there, how close the two results are?
So actually this botometer, they're doing a different thing compared to me. So usually they're actually using machine learning to detect bots. So if you give them an account, a username, it will tell you the score of the probability that an account is a bot. And it is just machine learning. And there are already many studies about machine learning for detecting bots. So actually, so what I like to do is not to use machine learning and do whatever everybody is doing, like characterizing bots from like different standpoints and perspective is also like important. So what they do is different. They're trying to detect, but what I did was that characterizing. So now we detected them. So let's see what are the differences between these fake accounts to real accounts. So it's like the next step after this like API.
All right. And then Cyril is asking, what was the size of your data set, and would you consider a larger set in the future work?
So I don't remember the size of the data set, but I can share it with you. Like these data sets are actually on this website, Botometer, the one that you just shared. They have all collections of bots-related data from Texas A&M, from University of Southern California. They're actually working with each other, and Pisa University of Italy, as well as Indiana University. All the data set is there, but it was huge. So like it makes it easy. It makes it easy to generalize the result and scalable, but I don't remember exactly the size.
Okay, and then do you have a clear plans for in terms of future work? How do you plan to expand what you've already done, or to refine what you've already done?
Yeah, chatbots. And more importantly, regarding like bots on other platforms, Facebook bots, like Wikipedia bots, do they have the same behavior or not? Like Wikipedia bots tend to be benign. So there are some of them who are like argumenting all the time, but Facebook bots are also important. But regarding elections, why I chose like Twitter, because research shows that people use Twitter for more professional stuff compared to Facebook. So like, as I'm sure you might see in many conferences, have a Twitter page. Many like faculties, even Indiana universities from this lab, many faculties, they have Twitter page. So they update their followers about what their research, conferences, so many things. So people go there to get the news of political stuff, like research and things like that. That's why the misinformation happens there more often than Facebook, which is more of a personal, you upload your picture, like going hiking, going out and things like that.
Okay, perfect. So we have exhausted all the questions. So thanks again for your presentation. Very interesting.
Thank you.
And we now have just a very short break, 5 minutes, and then I hope to see you all at the closing plenary session there for the conference in
Sure. Thank you so much.
Thank you. Bye-bye.
Bye.